We are now going to start section 4.4 on the fundamental theorem of calculus. We will not be doing a video on 4.3. That is not information that will be on any test or quiz. We don't need to worry about that for this class right now. All right, again, hopefully you have the notes on section 4.4, the fundamental theorem of calculus. This is very important. It is the fundamental theorem of calculus. All right, we went over before in class many times that differential calculus is basically the derivative. It is the change in y over the change in x. It is the limit as that distance becomes 0, and that gives us the slope of the tangent line. Well, now we've gone over that integrals are the area. It is the change in x times the change in y. It is the width times the height. And then we're adding up all of those rectangles. So the derivative and the integral are opposite operations. All right, so now we're going to go over what the fundamental theorem of calculus actually is. So we have the integral from a to b of f of x dx. Oh, I apologize. I don't know what just happened there. The integral from a to b of f of x dx equals, now we're going to say capital F of b minus capital F of a. All right, so what this means, we went over before that capital F means the antiderivative. So you're going to take the antiderivative of your function. You are then going to plug in the top number, that is b, get a value, minus, plug the bottom number into the antiderivative, get a value, and subtract it. So you're going to plug in the top, and you're going to take the antiderivative, you're going to plug in the top number, get a value, minus plug in the bottom number, and get a value. All right, so to start, we're going to do a nice one. The integral from 1 to 2 of x dx. So as I said, the first thing we're going to do is take the antiderivative. The antiderivative of x is x squared over 2. But now we are not going to write plus c. We're going to draw a long bar and say from 1 to 2. This differs from indefinite integrals. Indefinite integrals, what we did earlier in section 1, we write plus c on them. Here, if I have upper and lower bounds on my integral, we're going to evaluate and get a value for those. All right, so once we do our antiderivative, you plug in your top value. So it's going to be 2 squared over 2 minus, plug in your bottom value, 1 squared over 2. Well, 2 squared is 4 over 2 minus 1 squared is 1 over 2 gives me 3 over 2. And that is the value of the integral from 1 to 2 of x dx. That is the area on the curve. So hopefully we all know x looks like this. So between 1 and 2, the area between the x-axis and my function from x equals 1 to x equals 2, that area is 3/2, whatever unit it happens to be in. So that is what we found was the area. All right, let's do one more before we make it interesting. All right, for our second problem, we are going to do the integral. Didn't work. The integral, let's go from 1 to 4 of x squared minus 3 dx. So this is now a definite integral because we have our lower bound and our upper bound now given. So the first thing we're going to do is integrate. So that's going to be take the antiderivative. So it's going to be x cubed over 3, add 1 to the exponent, divide by it, minus 3x, and we're going to evaluate this from 1 to 4. All right, so now that means I plug in 4 and get a value. Then I'm going to plug in 1 and get a value. So that means it's going to be 4 cubed over 3 minus 3 times 4. So that's what I'm going to get when I plug in the 4. Then I'm going to plug 1 in for everything. So I'm going to get 1 cubed over 3 minus 3 times 1. So I'm going to plug the top number, I'm going to plug 4 into everything here, minus plug 1 into everything here. And then we just simplify it down. So 4 cubed is 64 over 3 minus 12, that's in my first bracket, minus 1/3 minus 3 in my second bracket. All right, now you can either get a value for your first bracket and a value for your second bracket and combine them. I think it's going to be easier for this one to distribute. I'm going to distribute the negative sign. So 64/3 minus 12 minus 1/3 plus 3. So I took this negative sign and distributed it to the 1/3 and the 3. Now I'm going to go ahead and combine like terms. So I'm going to get 64 over 3 minus 1/3 minus 12 plus 3. I'm going to do my fractions first. 64 minus 1 is 63 over 3 minus 12 plus 3. Well, 63 divided by 3 is 21. So I get 21 minus 12 plus 3 is going to give us an answer of just 12. So that is how we do a definite integral. So let's do one more, and then we'll move on to something else in this section. And this is a more difficult one. So the integral from 0 to 2 of the absolute value of 1 minus x squared dx. All right, we have never done absolute value in calculus before. We cannot do it now. There is no way to do an antiderivative or a derivative of an absolute value. So we need to understand what it means. All right, 1 minus x squared, if you go to your graphing calculator, is going to give us a v. So the first thing we're actually going to do to get where this change comes in and where the v part happens is to graph just 1 minus x squared. So I'm going to go on the side. So the graph of 1 minus x squared is an upside down parabola. All right, so x squared is a parabola, negative x squared, it's upside down, I moved it up 1. Well, here's the thing. What happens is that absolute value, it cannot be negative. It's going to take those negative values and make it positive. So instead of going underneath the x-axis there, it's going to go above the x-axis there. So it's going to flip whatever was underneath above, and we're going to get this. It's more like a W, but we only care about from 0 to 2. So it's going to V in the middle of that. So that's what our graph is going to look like. So here's the deal. How do I make that happen? How do I actually take what was underneath the graph and make it up? Well, the graph here between 0 and 1 is exactly the same. So I'm going to break this up, and I'm going to say the first half is the same as the integral from 0 to 1 of 1 minus x squared dx. But then I'm going to add to that the second half, which is going to be the integral of 1 minus x squared dx. But that's below the x-axis. That is down here. How do I flip it up? Well, I want the exact same area. I just want to change the sign of it. How do I change the sign of it? I multiply it by a negative. So instead of having a positive here, I need to multiply it by a negative so that it actually changes the sign. So I have to do two different integrals. I have to do one from 0 to 1 and one from 0 to 2. The first half from 0 to 1 is exactly what we like. The second half from 1 to 2, I have to change it a little bit. I have to change the sign of it to make it the absolute value part, the positive part. I'm running out of time on this video, so I will finish this in my next one.